Hi friends, welcome to the Unit 2, Day 5. We're still in the relations, functions, and graphs. This particular lesson talks about the toolbox functions and the transformations. When you think about a toolbox function, you're thinking about kind of the basics that you need to complete each sort of project that you're working on. So the toolbox functions are really just going to be the basic functions. Transformations is then what we apply to those to get the different shapes of graphs or equations or whatever we're working with. So each function belongs to what we call a function family, in which each family shares the characteristics of one basic graph, and we call it the parent function. So it says write the equation of the parent function and sketch the graph. So a linear parent function is just going to be y equals x. And if you think about that, that's going to be a diagonal line that goes through the origin. So if I think about like the points that are involved with this, y equals x. So it's going to look something like this. Looking for my straight edge. Here we go. And just doing a quick sketch. There we go. So there's the graph. So that's kind of an example of that one. Next one, we have the quadratic. So quadratic is going to be y equals x squared. Again, these are just really the basics. So this one, I have a point at 0, 0, 1, 1, negative 1, 1, 2, 4, negative 2, 4, and it makes that nice U shape. Flat here, flat bottom there. There we go. And then absolute value, that's going to be y equals the absolute value of x. And that gives us that V shape we've graphed earlier. Here. So again, the toolbox is just really the basics of all of these. So knowing these, and then knowing then what the transformations do, is key to being able to graph them effectively. And understanding just on the equation level what's happening with them. Cubic, so this is going to be y equals x cubed. Remember, these are all functions that we're working with, so instead of y, this could be f of x. Same thing. With x cubed, we're going to go here, and then 1 is 1, negative 1 is 1, but then 2 goes right off the graph. 1, 2, 3, 4, 5, 6, 7, yeah, just off. Same with there. So this one is a little bit tricky to do because you're making right like that, and then this one goes right like that. So it makes that nice vertical. It's very compressed with the cubic, very compressed in that nice squiggle. Square root, so y equals square root of x. So here, the domain and the range are restricted. 1, 1, 1, 2, 4, 1, 2, so 4, 2. Notice I'm getting at least 3 points for these. That's a good way to follow, to figure out kind of what graph you're talking through. Then the cubed root, y equals the cubed root of x. So 1, 1, and then negative 1, negative 1, and then it's just off 0, 0. So this one is just off. It's that next point. And then this one very similarly. So with a cube root, it actually looks more compressed, kind of vertically. It's squished, whereas the cubic one is kind of squished or compressed horizontally. So let's talk about the transformation. So here we have a bunch of different things, and the f of this f of is kind of like what's talking about the transformation. So let's think about what's going on here. If a is less than 0, think about that. If a is negative, then we reflect across the x-axis. So if this a value right here, that's negative, that's what it means by saying less than 0. If the absolute value of a is greater than 1, then what we have, if it's greater than 1, what we have is we have a shrink. But the way to think about it is more like it has a vertical kind of stretch or a pull to it. So it's like a vertical expansion. So this is let's call this a vertical stretch. Vertical stretch. If the absolute value of A is between 0 and 1, then we have a vertical compression. And then this B value right here, this is very similar to what we just talked about with the reflection and the vertical and the vertical stretch and vertical compression, except this is going to be a reflection across the y-axis. And then we have instead of a vertical stretch, now we have a horizontal stretch. Stretch. Helps to spell it correctly. My apologies. Stretch. And then a horizontal compression. Now, if you think about, you've got to be very careful with this. A horizontal stretch is the same as a vertical compression. If I'm stretching something, think about if I'm stretching taffy out, that's going to be the same as if I'm squishing the taffy. So think about that. So these two kind of, they correlate. You could have something affect one and it's the same as if it affects the other. So the question a lot of students have is, when do I know which one's which? And see what kind of the base transformation is, and then if it's giving you a list of options, just choose the one that makes the most logical sense. Sometimes it'll say vertical stretch or horizontal compression, because in that particular instance it can mean either. Here we have if x plus h, then this is going to be a shift. This is how we shift left or right. A lot of formulas have the x minus in it already, and we know that that is a shift to the right. If it's x plus h, then it shifts left. And then we know it's a shift left by that amount, by h units. And then this is a shift right by h units. And then if we add a k, that's going to be a shift up k units. And then minus k is going to be a shift down k units. So these are our basics and our transformations. Next, we're going to get into some examples on what we're doing with this one here. See you in the next video.